So welcome back, and in this particular video we will be discussing the problem rotate image by 90 degrees. So the problem is asking that we are given a n cross n 2D matrix representing an image. So we are given a square matrix. When we say that we are given n cross n, that is number of rows, number of columns will be same. In such a matrix which is representing an image, we have to rotate it by 90 degree in clockwise direction. So we have to rotate the matrix in clockwise direction by 90 degrees. So if we basically read the sample input and output, what is given in the sample input? If there are 3 rows, 3 columns, n is 3, then the matrix, if let's suppose it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 3 rows, 3 columns, 9 elements. After rotation by 90 degree, the elements should become 7, 4, 1, 8, 5, 2, 9, 6, 3. Similarly, for a 4 cross 4 matrix, if this is the input matrix, this should be the output matrix. So input matrix can be anything from 1 to 100. That is, number of rows can be anything from 1 up till 100. And the matrix will actually have 1 up till 10 raised to the power 4 number of elements. So if we read the remaining problem statement, we have to rotate the image in place. It means we have to modify the matrix directly. In place means we do not have to create a new matrix. We have to do the changes in the same matrix itself, which is given in the input actually. That is, there will be no return type. There is no expected output return type. We do not have to allocate another 2D matrix and do the rotation. So this is given in the note. So input format will obviously be a n number of lines, actually n plus 1. First line will be the n, that is number of rows, number of columns, square matrix, and then each row having some number of elements, the column number of elements, that is n number of elements. So if I take the same example, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the output for this corresponding matrix? The output after rotation is nothing but 7, 4, 1, 8, 5, 2, 7, 4, 1, 8, 5, 2, and then we can say it is 9, 6, 3, 9, 6, 3. So if this is R0, R1, R2, C0, C1, C2 of input, then this is R0, R1, R2, C0, C1, C2 of output. And what is this? This is rotation by 90 degree in clockwise direction. So is there any observation? Is there any relation between the input and output matrix? See, if we think in terms of the row 1, 2, 3. So where are the elements 1, 2, 3 in the output? The elements 1, 2, 3 in the output are in the column C2. The row 0 are now becoming column C2. Row R1 is now becoming column C1. And similarly, row R2, 7, 8, 9 is now becoming column 7, 8, 9. So the elements which were in a given row, they are in the output in the same column. And if it is such a thing, then what is the observation? We have to actually make the row elements become column, column elements become row. So one of the approaches, at least a brute force approach, if it was allowed to change the matrix, can be just create a new matrix and do the traversal column by column. That is, first traverse for 1, 2, 3 and store all the elements in the large column. Then traverse the next row and store all the elements in the previous column. Then traverse the next row and store all the elements in the previous column. If we are allowed to create a new matrix, then we can just in the input matrix traverse row by row, in the output matrix store column by column. But since the extra matrix is not allowed to be created, we have to do it in place. Currently the brute force will not work. We have to discuss some optimization. But time complexity, since we are going to do a simple traversal on both the matrix, it will be order of n square, where n is the number of rows or number of columns, and space will be order of n square again, because we are going to create a new matrix. So is there any better way in which we can not take any extra matrix and solve the same problem? See, if we have to make the elements at row become the element at column, similarly for next row, similarly for next row, first thing what we can think of in terms of matrix is, when rows become columns, columns become rows, this is nothing but making the transpose of a matrix or doing a transpose over a matrix. What is a transpose? A element at a row comma column will become a element at a column comma row. So for the same matrix, if I just write the transpose for this input matrix, if I write the transpose, what will happen? The element at I comma j will become the element at j comma I. So what will be the transpose matrix? So if I just show the matrix after the transpose, the columns will be C0, C1, C2, rows will be R0, R1, R2. But what about 1? R0, C0. After transpose, it will still remain R0, C0. So it will still remain here only. But the element at R0, C1 will go at the place of element R1, C0. 0, 1 will go at 1, 0. And same for 1, 0 will go at 0, 1. That is actually these two elements will get swapped. That is 4 will come here, 2 will go there. Similarly, what about 3? The element at 0, 2 will actually get swapped with the element at 2, 0. 0, 2 with 2, 0, I, j with j, I. That is, after swapping, the element here will be 3, here will be 7. What about 5? This is 1, 1. Row is same, column is same. I, j is I is 1, 1 only. So 1, 1 getting swapped with 1, 1, no problem, like no swapping at all. Same goes for 9 also. But finally, we should also be swapping for 6 and 8. That is, 8 will take the place of 6, 6 will take the place of 8. Why? Because 1, 2 will take the place of 2, 1. But is this what we need? Is this the output which we require? If we compare this intermediate matrix with the output matrix, we are still not to the target. We are still not covering the entire problem statement. We are not able to convert the input directly into the output. This was your input. This is your transpose matrix, which is swapping the values at R, C with the values at C, R. But now this matrix can be easily converted into the resultant matrix by again a similar observation. What is the next observation? See, if we think in terms of rows now, 147 in the output is a 741. 256 in the output is 852. Actually, this is most probably this was 8 only. I have not swapped. So this is 8, this is 6. Now if we compare, now it is correct. 147 147 from right side, or you can say 147 741. 258 852. 369 963. That is, each row is getting reversed. Each row is getting reversed. And if each row is getting reversed, we can, after the reversal of each row, say that finally, after these two steps involved, we are able to convert the input matrix into the output matrix. But the point is, we are going to apply these two steps in in which kind of manner, so that it is in place, so that it is not taking any extra space. See, if we know how to reverse a 1D array, then it is also easy to reverse a row of a given matrix, because a row of a given matrix can be taken as a 1D array with some particular index. That is what we used to do in reversing a single array. We used to take array of left and array of right and used to swap the left value with the right value. But this time what I will do, or what we will do, we will say matrix of a given row and the left column will get swapped with matrix of a given row with the right column. So the given row can be 0th row. That is 0th row, 0th column with 0th row, second column getting swapped. Then row plus plus for the left, actually column plus plus for the left, column minus minus for the right. So as soon as they meet, we will stop. Same goes for the next row. Same goes for the next row. So for each row, we are about to reverse each and every row using a 2-pointer technique. So we know how to reverse using 2-pointer, but how to do transpose? Transpose is a relatively new term. See, if I am going to run a loop on entire matrix, and if I am going to swap R, C with C, R, we already know how to swap two elements by using a temporary variable. But if I will swap 1 with 1, no problem, you can do it. 2 with 4, okay, 4 and 2 swapped. 3 with 7, okay, well and good. But should I again swap 2 and 4? Should I again swap 1, 0 with 0, 1? No. If these two elements are swapped 2 times, they will become the same array. No two elements, no two pairs, no two elements in a single pair should be swapped 2 times. Otherwise, it will give you the same matrix. So how can I prevent 2 swapped with 4 and again 4 swapped with 2? How can I prevent 2 times swapping? We can just only say that upper half of the matrix will get swapped with the lower half. That is, all the elements which are above the diagonal will get swapped with the elements below the diagonal. That is, 2 will get swapped with 4, but 4 will not get swapped with 2. That is, you can say 0, 1. We will run a loop, but we will not run a loop for 1, 0. We will only run a loop in the outer upper right triangle. That is 1 getting swapped with 1, 2 getting swapped with 4, 3 getting swapped with 7, 5 getting swapped with 5 itself, 6 getting swapped with 8, 9 getting swapped with itself, and that's it. No need to run the loop over 4, 7, and 8 respective indices, because if we are going to run it, then it will actually do 2 swappings. So 2 steps overall. First step, to run a loop on the half of the matrix, that is upper right triangle, and swap r comma c with the c comma r in order to make the columns become row become column, just on the basis of observation. As soon as we are able to do it, this is not the required matrix. To make the intermediate matrix convert into the required matrix, that is rotated matrix, what we need to do, we need to reverse each and every column. You can also think in terms of that we have to swap the columns, that is make C0 become C2, make C2 become C0. But thinking in terms of reversing a single row will be easier. So second step will be run a loop on every row and reverse it using a 2-pointer technique. What will be the time complexity to do a transpose? Since we are going to run a loop on upper half triangle, it will be order of n square, because almost upper half will have n into n plus 1 by 2 a number of elements in worst case. So it will be order of n square. What about the reversing each and every row? Since I am going to run a loop on every row and reverse it, running a loop on every row n, reversing a given row using 2-pointer again n. So n into n. This will also go n square. But will the time complexity be n square into n square or plus n square? It will be plus, because first we are applying this, then we are applying this. Both are steps one after the other, not one inside another. It is not nested. First we will do the transpose. Once it is done, once we are getting the intermediate, on the intermediate matrix, we will be applying the reversing of each row. So overall time complexity will be quadratic in nature. What about space? Are we going to use any extra space? Actually, no, we are doing it in place. We are just changing the same matrix itself, which we are getting in the input. So let's quickly now basically go through the third milestone. With that, we have actually covered the second milestone, that is coming up with the approach. So third milestone is going and writing the instruction manual. So in the instruction manual, first of all, in the rotate image function, what we need to do? We need to do 2 steps. Step number 1, transpose the matrix by calling a function. Most probably we should have a separate functions for both the steps. Call the function transpose, where I will pass the matrix, and the expected output is not the output actually, but the expected logic is it will make all the rows columns, column becomes rows. So call the function transpose by passing the matrix. Then step number 2 will be call the function which is nothing but reverse each row by passing the matrix again. So both functions will be taking the matrix input but not returning anything, because return type is void. We have to do it in place. So public void, first of all, transpose we have to create, in which we are going to pass the matrix, and the expected code is that we have to run a loop in the upper right triangle. That is for all elements where row should be lesser than equal to column. That is, if row is 0, column can be 0, 1, 2. If row is 1, column can be 1 or 2. If row is 2, column can be 2. So column should be greater than equal to row. So I will be running a loop for all the rows. That is for int row is equal to 0 till the last row. So actually we have to write the pseudocode. So what we have to do is run a loop over all rows, starting from zero till the last row. So how can you get the last row in particular to some languages where you are not getting the input as the number of rows? You can just calculate matrix dot length, or you can also calculate matrix of 0 dot length, depending on if it is a square matrix or a rectangular matrix. If it is square, you can use both rows and columns as matrix dot length itself. So first of all, we are basically running a loop over all rows, then run a loop over columns from the rowth column till the last column, and now swap the values present at row comma column with column comma row. That is, make the column become row, make the row become column. This is the first function. You can use the inbuilt swap function. You can write your own logic for swap. It is up to you how you can write it. And then the second function will be to basically reverse each row. So for reversing each row, we have created a function reverse rows, where again we will be expecting a input in matrix. And for this, first of all, we have to run a loop over all the rows. So run a loop over all rows starting from 0 till the last row. And now once we have fixed a row by using row pointer, now we will run a two pointer technique over the columns, that is left as 0, right as the last column, and using these 2 pointers we are going to reverse the basically that particular column. So how we can reverse a particular column, or how we can actually reverse a particular row by swapping the elements? We can say swap the values present at the current row comma left column with current row comma right column, because row will be same, only the column will be left and right, because we have to apply the 2 pointer on the column. Left column, right column, row will be same because it is treated as a 1D array. After swapping, what we used to do in 2 pointer, we used to do left increment by 1, left should be increment by 1, but right should be decrement by 1, but right will be decremented by 1. And finally we are able to basically reverse each row also, and with that we will be able to do the entire logic. So run a 2 pointer over column till the point the left column is actually smaller than right column, because 2 pointer will only run if there is some certain number of columns left. So this is the entire code which we have to basically, this is instruction manual actually, which we have to code in the next part, in the coding the problem rotate image in Java language. And for that, first of all, we were expecting two parts. That is, first was the transpose part, second was the reverse rows part. In the transpose part, what we did, we just simply, we will call the function transpose and we will pass the matrix. Same goes for reverse rows. So I will just simply call the function reverse rows and pass the matrix. And I will expect that both will do their work. So first of all, let's try to code the transpose function. What we have to do in transpose, as discussed, we have to run a loop in the upper right triangle and swap every value at row comma column with the value at column comma row. So run a loop on all the rows, that is row 0 till row less than matrix dot length. Last row will be n matrix dot length. And once we are running a loop over all the rows, we have to do what? We have to run a loop over all the columns till the starting from the rowth column till the last column. That is, for column equal to row, column will be less than matrix of 0 dot length. You can also use matrix dot length because it is a square matrix, and column plus plus. And now what we have to do? We have to basically swap the values present at row comma column with column comma row. So I am quickly writing my own swap logic. You can also use inbuilt functions if they are present in your particular language. So I will be passing the matrix. I will be passing which cell, that is which coordinate, and which another cell, that is which another coordinate I want to swap. R1 comma C1 should be swapped with R2 comma C2. So how we can swap? We can make a temporary variable of matrix of R1 comma C1. Then matrix of R1 comma C1 will become matrix of R2 comma C2. That is, make A is equals to B, make B is equals to C, and then finally make C is equals to back to temp. So R2 comma C2 will become temporary variable. So this is how you will swap. So what we need to do? We need to call the function swap, where I will pass the matrix and I will swap row comma column with column comma row. So row comma column will be swapped with column comma row. So R1 C1 will be row call, R2 C2 will be call row. Once we have transposed, let's see if we are actually getting the correct output. For now, I am letting the reverse rows function be empty, so that we are able to get whether the transpose is working fine or not. For 1, 2, 3, 4, 5, 6, 7, 8, 9, transpose should be correct. But currently there is some certain semicolon issue. Okay, now I have added the semicolon. Let's now run it again to see if we are actually able to do the transpose. And there is certain function name error. So we are having function name as a transpose, not transpose. So let's run it again. There are certain like logical errors, or you can say syntactical errors. So obviously output will be wrong, because for now we have only implemented the first step. But after transpose, 1, 2, 3 is now actually in the first column. then second row is in the second column in the actual output. 7, 8, 9 is actually in the last column. So a given row is becoming a given column is becoming a given row. We are able to do the transpose. Now let's also do the reversing of each row. So for that, again, run a loop on every row, because we have to check that for a current row, it should be having all the elements which used to be left to right, now should they become right to left. So for that, run a two-pointer technique. That is, initialize a left pointer as 0, initialize a right pointer as the last column, matrix of 0 dot length -1. This is the last column. And do what? Run the two-pointer only till the point while left is smaller than right. Till this point, we have to run the two-pointer technique. And every time what we need to do, we need to swap the values present at in the matrix of row comma left with the matrix of row comma right. Once we have swapped, what we need to do in two pointer, when both the pointers are moving towards each other, left will become plus plus, right will become minus minus. So this is how you will reverse a given row, and this is how you will reverse each and every row for the entire matrix. So let's now run it again, and now output should be the same as the expected output, because now we have implemented both the steps and actually it is giving me the same output. Let's do it for an even number of rows or even number of columns also, that is 4 rows 4 columns. It should work fine for 4 rows also. Let's see if it is working fine or not. And let me actually copy the last row. Let's run it again to see, and then we will actually submit. So code is also working fine for the 4 number of rows, 4 number of columns, and we are able to get all the test cases correct. So this is the problem, rotate image by 90 degrees. This is the code. How much is the time complexity as discussed? N square. How much is the space complexity? Space is only and only constant, no extra space, in place solution, because we are changing the same matrix itself. Now, some follow-up questions which you can try it on your own can be, instead of rotating 90-degree clockwise, what if you have to rotate 90-degree anti-clockwise, or 270-degree clockwise, or 180-degree clockwise? So all these types of rotations can be your homework problems, and you have to try them again without taking any extra space. That is, you have to do in place. So you can think what will be the time complexity for them, what will be the approach for them. Till then, let's meet in the next video. Bye bye.